Hello, this is 7.1 arithmetic geometry sequences. Objectives for this one sequences notation, arithmetic sequence, and geometry sequence. So, sequence notation. So, what is a sequence? Sequence is the most often the list in which the pattern can be determined. So, there's some pattern going on here. So, consists of following the sequence. I have a rectangle, triangle, rectangle, rectangle, triangle, triangle. So what are you expecting after? So I want to say there might be a 3 rectangle and 3 triangle. And then after 4 rectangle and 4 triangle. And then keep adding the one more rectangle and triangle to continue that pattern. So what we just say at the next 3 terms of the each sequence, okay? So in this section, a sequence will be the list of numbers in which the numerical pattern exists. The following are example of the algebraic sequence. So 5, 8, 11, 14, 17, 3, 6, 12, and 24. 1, 1, 2, 3, 5, 8, 13. So do you see each pattern? So when I look it up, the first pattern, 5, 8, 11, 14, 17. So it looks like you're adding 3 up to get another numbers, adding 3, 20, adding 3, 23, 26, 29, go on, right? But the second sequence is 3, 6, 12, and 24. Okay, the next number is the twice of the first numbers. You gotta multiply by 2. So 24 times 2 is 48, and then 96, and go on. And then 1, 1, 2, 3, 5, 8, 3. Oh, it doesn't look like any pattern to me, but what I notice is, okay, uh, if you think about any number before, it's a 0. So 0 plus 1 makes a 1. And also 2 is going to be 1 plus 1. And 3 is 1 plus 2. And then 5 is 2 plus 3. 8 is 5 plus 3. 13 is 8 plus 5. So now 13 plus 8 is 21. And 21 plus 13 is 54. 54 plus 21 is 75, you know. Yeah, see that? We call this kind of pattern too. So do you see the each pattern? Can you determine the next 3 terms of the each sequence? So in the first example, 5, 8, 11, 14, 17, we may notice that each term is previous term plus 3. So using these rules, we can determine the next few terms and extend the sequence as 5, 8, 11, 14, 17, 20, 23, 26, and 29. In the second example, 3, 6, 12, and 24, we may notice that each term of the previous term multiplied by 2. Using this rule, we can determine the next few terms and extend the sequence as 3, 6, 12, 24, 48, 96, and 192. So keep multiply by 2. In the third example, 1, 1, 2, 3, 5, 8, 13, it may be more difficult to spot the pattern. So this sequence is called the Fibonacci sequence, in which each term is found by adding the 2 previous terms. Using these rules, we can determine the few next terms and extend the sequence as 1, 1, 2, 3, 5, 8, 13, 21, 34, 34, and 55. So in this section, we'll study 2 specific type of the sequences, arithmetic and the geometry sequence. So 5, 8, 11, 14, 7, we call the arithmetic sequence because this is adding by 3, okay? So when you're adding or subtracting by number, we call the arithmetic sequence. And then second one we call the geometry because we multiply by 2. So when you multiply by 2 or when you divide by any number, we call the geometry sequence. So to begin our discussion of the sequence, we must introduce a notation that is in verb. So a sequence can be described by a function with a natural number as the domain, and with instead of using function notation, sequence use a subscripts. So this is actually we use as domain 1, 2, 3 through the n, which is all. This is a natural number, which means 1, 2, 3, 4, which is a counting number. So when you see the 1 as a sub number, we call the first term, 2 second term, 3 is third term, and then which is we call the nth term, or you can just say general term, which give us a formula for the sequence. We can describe our sequences with the general term in putting any natural number into n to represent the position that the number possesses in the sequence. So determine the first 5 terms and then 12 terms each of the following sequence described using the general term. So find the first 5 terms and then the 12th term. So this is general term. So first term means you need to use n equal to 1. So 3 times 1 plus 2, which makes a 5. So first term is a 5. Second term, 3 times, now n is a 2, which is 8. And third term, 3 times 3 plus 2, which is 11. 8 times 4, 3 times, now n is a 4, 14. And is a fifth because first 5 terms, so 3 times up. 5 plus 2, which is 17. You also need to find the 12th term, which is now n is a 12. So 36, 38. Okay, so that's the answer for example 1. Now example 2, same thing. A sub 1, 3 times 2, 1 minus 1, which is 3 times 1 minus 1, 0 power, which is 1, 3. And sub 2, which is 2, 2 minus 1, so 3 times 2, which is a 6. A sub 3, 3 times 2, 3 minus 1, 3 times 2 square, 4, 12. A sub 4, 3 times 2, 4 minus 3, which is 3, 2 cubed, which is 8, 24. And then a sub 5th, which is 3 times 2, 5 minus 1, 3 times 2 to the 4th, 16 times 48. And then a sub 12, you got 3 times 2 to the 12 minus 1, so 3, 2 to the 11. I think I want to use a calculator. So 3 to the 11, 2 to the 11th power, and then times by 3, I got 6,144. So geometry sequence, actually the number value increases very quickly. So arithmetic sequence. The first type of the sequence that we'll study is called the arithmetic sequence. Arithmetic sequence is a sequence in which every successive term is found by adding a constant called the common difference, which is called the d, as to the preceding term. The sequence we discussed earlier, 5, 8, 11, 14, 17, is an arithmetic sequence in which every term is found by the adding 3 to the previous term. Shortly, we will see why the number 3 is called a common difference, denoted as a d equal to 3. Although the many sequences can be determined to be the arithmetic by inspection, there is a following test that can be applied to determine the even given sequence is arithmetic. Because if you are subtracting the next two term each other from the next to the previous, okay, always you try to get the d as a common difference. So in order to find the common difference, you have to subtract from the next term to the previous. So a minus 5, 11 minus 8, 14 minus 11, and 17 minus 14. And then as you notice, everything come out as a 3. And then we can say this is our arithmetic sequence, okay? So in order to find that in example 2, determine if each of the following sequences is our arithmetic sequence. So same thing. So negative 3 minus negative 8, which is a 5. 2 minus negative 3, which is a 5. 7 minus 2, 5. 12 minus 7, which is 5, 2. So d equal to 5. So yes, this is our arithmetic sequence. Now 6 minus 2, 4. But 18 minus 6 is a 12, which is 4 is not same as 12. So this is not our arithmetic sequence. Now 1 minus 9 is negative 8. Negative 3 minus 1 is negative 4, which is this is not the same. So this is not our arithmetic sequence. So in order to work more efficiently and answer questions regarding each of these sequences, we turn our attention to finding the general term that can be represented each of these arithmetic sequences. Consider any arithmetic sequence with the first term is a 1 and common difference of d. So second term always adding the d from the first term. Third term means second term adding the d. But the second term same as a sub 1 plus d. So if you simplify, there's a sub 1, but now you have a 2d. Now for the first term, now you have a 3d. For the fifth term, you have a 4d. So we get the form of this, okay? So when we have a sub n, which is gonna be the nth term, then a sub 1 adding to the always take away from the whatever number you're looking and then multiply by d. And also, what if you don't have a first term? So we can use any term in the sequence, which is, but n is always greater than k. So we put the a sub n value, a sub k value, and then n and k subtracted and then multiply by d. That's another way you can find the any number in that as a general term. So determine the general term of the sequence, which is, yeah, but this one a sub 1 is a given. So I'm using a sub 1 plus n minus 1 times z. So a sub n is, so whatever first number is always a sub 1, so negative 8. And then n we don't know. And then d is subtracted. So negative 3 minus 8, 2 minus 3, 2 minus negative 3, 7 minus 2, which is a 5. So if you simplify, you get negative 8 plus 5n minus 5. You can say negative 5n minus 13. All right, next one. Okay, so a sub n, a sub 1 plus n minus d. So a sub n, a sub 1 is actually the 9. So 9 plus n minus 1, and 5 minus 9 is negative 4. So in order to find that, 9 and multiplied by negative 4, you got negative 4n plus 4. And then we get negative 4n plus 13 is a general term. All right, next one. So example 4. So determine the general term of the arithmetic sequence with a fifth term and a 10. And then the 21st term is 58. Oh, I'm sorry, I don't have enough space here. So I tried my best, okay? I should make more space here. So a sub 5 is a 10. A sub 21 is 58. So this time I'm using the a sub n is a sub k plus n minus k to the d. So a sub n, which means I want to say n is always bigger than k. So n is 21, then k is 5. So a sub 21 equal to a sub 5 plus 21 minus 5 times d. But a sub 21 is a 58 and a sub 5 is a 10 and plus 21 minus 5 is 16d. And then subtract 10 both sides. I got 48 equal to 16d. Divided by 16, d equal to 3. So now we have to find the a sub, to find that here. So we have a sub n equal to a sub 1, n minus 1 times d. And then a sub n is, let's use a 21 if you want, or 5, okay, so 5. And the a sub 1 is we don't know. And the n is going to be the 5 minus 1 times 3 as a d. A sub 5 is a 10. So a sub 1, 5 minus 1 is 4 times 3 is 12. And then subtract 12 both sides. It's going to be negative 1. Okay, so we got the form a sub n is a sub 1, which is negative 2 plus n minus 1 times d is a 3. So if you distribute it, you got 3n minus 3. So this is 3n minus 5. I'm sorry about the space, okay? All right, so that's for example 4. So after finding the general term of the arithmetic sequence, there are essentially two types of question that can be asked even if they are asked using different language. So number 1, given position, find the number in the specific position, and given a number in the sequence, find its positions. So position means n and k, and then the number is going to be the a sub n equal to what? To answer these questions, we must remember the following. So n means the position of the given number. A sub n is a number in that position. So example 5. Record the arithmetic sequence negative 8, negative 3, 2, 7, 12, which was found to have a general term form of a sub n is 5n minus 13. So they're asking for the find the what value in the 96th place and 147th place. So a sub 96, I got 5 times 96 minus 13. And then you can just use calculator, say 5 times 96. and minus 13. I got 467. A sub 147. I put 5 times 147 minus 13. So 5 times 147 and subtract the 13. I have 722. What position is the number 602 in the sequence of negative 8, negative 2, 2, and 7, and then 12, and all the way to 602? So I'm not looking for the what a sub n here. I'm looking for that n, okay? So in here, okay, so I'm using the a sub n equal to a sub 1 plus n minus 1 times d. So a sub n, I got 602 because I don't know about n yet, right? But a sub 1 is negative 8 in the sequence. I don't know about n, but I know the difference, which is 5. So I'm going to solve for n. So 602, negative 8 plus 5n minus 5. I got 602 equal to 5n minus 13 and plus 13 both sides. I got 615, and then n equal to 615 divided by 5. So I got 123, which means position of the what? 103rd place. 120 third place. How many number are the sequence of in here? So how many numbers are in the sequence we have? So there will be a 123 numbers. Okay, because A is A sub 1 and this is the A sub 120, which is there are 123 numbers. Geometry sequence. The second type of the sequence that we'll study is called the geometry sequence. A geometry sequence is a sequence in which every successive term is found by multiplying a constant called the common ratio. So you multiply or divide by to the preceding term. So the sequence we discussed earlier, 3, 6, 12, and 24, is a geometry sequence in which each term is defined by multiple by 2 to the previous term. So shortly we will see why the number 2 is called the common ratio. Sorry about that. Ratio, and the denoted is r equal to 2. So there is a test can be applied to determine if a given sequence is geometry, and then we'll find the ratio as this. So this is about division. So second term divided by first term, third term divided by second term, and fourth term divided by third term. And then you'll get the same number, and then we'll see as this is a geometry sequence. As you notice here. So 6 divided by 3, 2, 12 divided by 6, 2, 24 divided by 12 is also 2, 2. So since every ratio is 2, and then it's a geometry sequence. So example 6. Determine if each of the following sequence is a geometry sequence. So 4 divided by 1, 4. 9 divided by 4, which is not 4. So nope, this is not a geometry sequence. 6 divided by 2, 3. 18 divided by 6 is a 3. 54 divided by 18, which is a 3. So yes. 2 divided by 3 is a 2/3. 4/3 divided by 2, which is same as multiplied by 3 both sides. You got 4 over 6, which is a 2/3. Okay. And then 8. 8 over 9 divided by 4 over 3, which is the same as times by 3 over 4, which is cancel, and 2/3. So everything turned out 2/3. So yes, this is a geometry sequence. So now in order to determine the general term of the geometry sequence, consider any geometry sequence with the first term a sub 1 and common ratio r. And the second term is going to be you multiply, keep r to get the next term. So for the a sub 3, multiply another r for the a sub 2. But if I replace the a sub 2 as a sub 1 times r, and then you are multiply another r. So maybe multiply r. Okay, so as a form, your general term is always first term times r to the n minus 1, or you can use any terms in the sequence too. So we can use this formula to find the general term of any geometry sequence, determine the general term of the sequence. So a sub n is a sub 1 times r to the n minus 1. So a sub 1 is 2 times, r is 6 divided by 2 is a 3 of n minus 1. So this is a general term. For B, a sub n is a sub 1 times r to the n minus 1. So a sub 1 is 3 of r is 2/3 and n minus 1. So determine the general term of the geometry sequence where the third term is 48 and the sixth term is 3072. So at this time, I'm going to use a sub n is a sub k times r to the n minus k. Alright, so n is always bigger than k, so I want to say n is a 6 and k is a 3. So a sub 6 is a sub 3, r we don't know, right? And n is 6 minus 3. So a sub 6 is turned out as 3072, a sub 3 turned out as 48, r cubed. Now divide by 48 both sides. So 3072 divided by 48. I have a 64 as a r cubed. And then cube root both sides, r equal to the 4. So we need to find the a sub 1. So a sub n is now a sub 1 times r to the n minus 1. So n this time I want to use a cube. So a sub 3 is a sub 1 times r is a 4. N is a 3 minus 1. So a sub 3 is a 48. A sub 1 and then 3 minus 1 is 2. 4 squared is a 16. And then a sub 1 is 48 divided by 16. And then I got 3. Okay, so our formula is a sub n is a sub 1, which is 3 times 4 to the n minus 1. Just as arithmetic sequences, once the general term is found for the geometry sequence, there is essentially two types of the questions can be asked. Number 1, given a function, find the number in the specific position, and given a number in the sequence, find its position. So for either question, we must again remember the following: n is the position of the given number, a sub n is the number of the nth position. So example 9. Recall the geometry sequence 2, 6, 18 to 54. Which of the findings have the general term as this? And then find the eighth term. So a sub 8 is 2 times 3 to the a minus 1. So it's a 3 to the 7th power. So we got 2 times of 3 to the 7th power. Then I got 4,374. As a b, what position is the number is a 13,122 in the sequence of 2, 6, 18, 54. So a sub n is a sub 1 times r to the n minus 1. So a sub n, we're looking for the what is n is, okay? So a sub n is we know. So this is a sub 1 and this is a sub n, but we're looking for what is n. So as a sub n, I got 13,122. A sub 1 is a 2 times r is a 3 to the n minus 1. So divide by 2 both sides. 13,122 divided by 2. I have 6,561, which is a 3 to the n minus 1. And then I'm looking for the 651 as what 3 to the what power here. Okay, so 3 to the what power should be 3 to the what power equal to, let's put the ln. We can do that too, right? Or log, whatever. Because we are yeah, I think let's use the one that we know, okay? Then I'm gonna put the ln both sides. Or log base 3, okay, I can do that. So log base 3 of 6,561. Log base 3 of 3 to the n minus 1. So I got log, which is this is the same as log of base 10 of 6,561 divided by log of 3, which is now n minus 1. So log of 6561 and divided by log of 3. It says 8. So 8 equal to n minus 1 plus 1 both sides, n equal to 9. So it's going to be how many number? 9th place. Alright, that's all. Thank you for listening.